also Professor Shiv Kumar, who is the co-convener of Mantana, the research cell. I welcome all the participants who have joined us on this day to hear Ms. Chandana Prakash on this day for the webinar on artificial intelligence in digital era. A warm welcome to all the participants, students, and heads of the institutions of Sheshadripuram Educational Trust who have joined us today. Also, Professor Shiv Kumar, who is the co-convener of Mantana, the research cell. I welcome all the participants who have joined us on this day to hear Ms. Chandana Prakash on this day for the webinar on artificial intelligence in digital era. Yeah. Sorry for this. Maybe we have live streamed in YouTube, so we have heard a echo of that. Now I request Assistant Professor Spandana to introduce the resource person to the session.
Thank you, ma'am. To give a brief introduction to Chandana, madam, she has 7 years of work experience in the tech industry and specializes in search optimization. She currently works at Amazon on the sponsored products team. She holds a master's in computer science from University of Southern California, multiple patents in database performance optimization, and serves as the chapter lead for Amazon Women in Engineering. She's passionate about spreading the word of wonders of computer science and the potential for technology to change the world. It is our pleasure to have you among us today, ma'am. Again, a very warm welcome to you. I would also like to take this opportunity to welcome our beloved principal, Professor Vidya Shivananavar, madam, for this session. Welcome, ma'am. Chandana, ma'am, over to you.
Thank you so much for that extremely warm welcome. I hope everyone can hear me and see my screen and see me. If not, leave a comment. I'll try to keep an eye on the comments to see if there's anything that needs to be addressed right away. With that, hello everyone. Very good morning to all of you, and thanks for making the time to attend this session. As Spandana ma'am already introduced me, my name is Chandana, and I am extremely delighted to be talking to all of you today. Okay, before we get
Ma'am, your audio is mute, ma'am.
Can you hear me now?
Yes, ma'am.
All right. Let me keep the chat on in case. So did it just go on mute? Do you want me to restart? Did you hear anything at all?
So, ma'am, we want you to restart again, ma'am.
All
It's
right,
completely
cool.
mute.
All right, sounds good. Thank you. I am on unmuted now. I hope everyone can hear me and see me now, and I hope you can see my screen as well. Hello, everyone, and a very good morning to all of you. Thank you so much for making the time to attend this session. As Spandana already introduced me, my name is Chandana, and I'm extremely delighted to be here and be talking to all of you today. Before we get started, since we're doing this virtually, I think we'd like to see if we can make it minimally interactive. Won't be asking you all too many questions, just a few to get the conversation kind of started and for me to understand the crowd better. How many of you here have heard the term machine learning? If you have, then could you type A+1 in your chat window? I will, because I have heard of the term. And this will kind of give me an idea of what the crowd knows and if you people have already heard of the term. Probably give you a few seconds if you have. Great. Anupam says he has. Rahul has. There are a few people who have. Rahul also has. That's great. So there are quite a few people who have heard of the term machine learning itself. I think one more question that I'd like to kind of see to understand a little better is, what is your current specialization? Is it finance? Is it accounts, HR, general? Feel free to type it again in the chat. Mine is computer science in search. I see Mohammed from finance, Rahul finance, Charan from finance, Karthik from finance. Wow, we have a huge finance representation. Ananya is from finance as well. Great. So we have a huge finance representation. That's great. So we can talk about examples accordingly in machine learning and AI as well. Not so relevant question, just to kind of conclude this. What's your favorite T20 cricket team? Mine has to be number 1, RCB, number 2, Mumbai Indians. Any other favorites? RCB? Gautam's RCB, Aishwarya's RCB. Oh, wow. Okay. The chat's kind of just flooding with RCB. I do see one Mumbai Indians. I see a lot of RCB. So a lot of like Bangalore patriotism right here. That's great to see. Wow, there's a lot of feedback suddenly when we talk about RCB and Mumbai Indians. That's great to see, though. Thank you so much for the participation, all of you. I think at least through this, I learned a little bit about you all. And see, there's like Lokesh likes RCB a lot. It's like RCB into 4. A little bit about me, because now I learned a little bit about you all, right? I've been an Amazon engineer for 3 years. I specialize and work in advertising technology and work with AI almost on a daily basis. So besides this, currently I live in Seattle. And prior to this, I was building the foundations of diverse data sets interacting with each other at Teradata for about 3 years in Los Angeles. Besides this, currently I run a small team within Amazon called Amazon Women in Engineering. It's a diversity group. It's a small group of women in tech. We do a lot of like serious things, a lot of fun things. We have a lot of diversity discussions. We have book clubs. We play a lot of games. There's a lot of knowledge transfer that frequently happens about latest technology. We also have a lot of mentoring sessions, among many, many other things. At Amazon, as well as outside of Amazon, I love sharing my knowledge with others and also learning from others. So I'm going to try and do the same thing today and share what I know about AI with the rest of you. With that said, I'm for now going to turn off my video just to make sure the bandwidth and everything is still fine for the rest of the presentation. I'll probably turn it back on later at the end for Q&A. I see that my screen is still being shared and I'm unmuted. So with that, let's continue. Overall, here's kind of what you can expect from today's talk. We will briefly talk about AI, what it means, what are some of the use cases to kind of make it a little bit more relatable, and how you can be a part of this revolution as we know it. And if you have any questions that you'd like me to cover, we'll save some time towards the end and we can get to all of those in the end. With that, let's get started. AI, right? What is the big deal about AI? We've heard so much. When people say AI, they actually mean so many different things. They mean machine learning, they mean computer vision. You see decision making on this. You see information retrieval, data mining, human computer interaction, robotics, planning, NLP, which stands for natural language processing, deep learning, speech recognition, etc., etc. And it goes on. These are only some terms in which you might have heard AI as a specific context itself, but you can think of all of these as some fields of AI. And each one of them itself have many, many subfields under it. So machine learning itself has tens of subfields under it, which itself, again, will have many, many more subfields under it. We won't go into the details of all of these and all of the topics listed here, but we'll broadly think of these as different types of AI. Or you can also think of it as different domains in AI specifically. So what is the difference really between all of these different terms, right? Mainly, they're just basically different use cases. They differ based on their applications. They differ based on the projects where they may be used and the domains where they may be used. Let's clarify some important terms with that said. With this slide, I want to talk about 4 main things: data science, artificial intelligence, machine learning, as well as deep learning. I'll start with artificial intelligence first, and then we'll move on to the others. And when I say AI for the rest of the talk, I'm actually referring to artificial intelligence. I'm sure we all agree, speaking of AI generally, that human beings are some of the most intelligent living beings we know with very complex decision-making capabilities. And given that fact, let's compare the basis of artificial intelligence with human intelligence. Humans are able to perform certain actions and make certain decisions as well. And given that context, what is AI? Any technique that enables a computer to do the same thing that a human does or human intelligence does. So any technique that mimics what a human intelligence does independently by itself is nothing but AI. So for an example, if a computer is trying to understand logic, that is AI. If a computer is trying to make decisions, that is AI. This AI topic is the broadest topic that you will hear in this whole family of different topics that do exist. And we'll go into like plenty of examples later in each one of these categories as well. Moving on, a subset of AI, as we see in this diagram, is machine learning, or otherwise also shortly called ML. One advantage of that machines have is that they can process huge amounts of data, obviously much more than humanly possible in a given amount of time. So when machines use this big data along with statistics to improve any tasks that a machine is performing and to be able to make predictions, for example, with historical data, it's called machine learning. And that's kind of why it is a subcategory of AI. One example of machine learning that I'm sure a lot of you, because you were talking about finance, that you might relate to, is predicting credit worthiness of a loan applicant, or otherwise also called credit risk modeling, where the goal is to use some kind of financial data that we may have about these people to predict if they will default risk or not, right? And I'm sure there are many variables that go into deciding what creditworthiness really is. And I think all of you may know these details better than I do. But the main difference between doing this, at least statistically, and doing it from an ML perspective, because it can be done in both ways. When you're doing creditworthiness, you can predict it statistically, you can do it using machine learning. So why ML in this particular use case? Typically in statistical learning methods, we assume some kind of formal relationship between the variables in the form of mathematical equations. But in machine learning, the advantage is we can use these methods to learn from data without really requiring any rule-based programming. So it just makes it more flexible, and these machine learning methods can better fit patterns in data that's very varied. The other advantage in this very context of loan application is that with ML models, they can read abundance of data samples collected on, say, an example that's taking a loan. So they can look at what are the past trends, if they have made the loan payments on time or not, how healthy were their accounts in the past based on the loans that they have taken in the past, and kind of use all of this data to crunch some numbers and get results in a matter of seconds in an unformulated manner, in a more free-form manner. And that's kind of the advantage that ML has over statistics in this specific example. The other little circle that you see down here, which is actually a subset of even machine learning, is deep learning. Deep learning is composed of algorithms that allow a software to kind of train itself and perform these tasks by itself. I want to go back to the human ontology example that we were talking about here and human analogy itself. This is almost like how a human brain functions or behaves. A human brain has thousands and thousands of millions of neurons, which enable it to behave in almost an independent manner and make all of these cognitive decisions. So trying to replicate something like that is called deep learning. So an example to understand this better would be something like image recognition. Facebook has a feature actually that uses image recognition that I'm sure you've all seen before. When you upload a photo on Facebook, Facebook recommends like suggestions of who to tag in this photo. What basically Facebook is doing behind the scenes is using facial recognition on these images. And facial recognition is an example of deep learning. More recently, another example that you might have seen is with deep learning itself is also voice recognition. Voice recognition is another subfield. Like I said, each of these have so many subfields under them. Example of voice recognition could be something like voice assistants that you might have seen and heard or maybe even use. For example, when you say, Alexa, what is the weather like today? Behind the scenes, there are a lot of complex artificial intelligence models that are built, and these are able to perform some real-time analysis of the voice itself and be able to derive meaning from there. One more like very relatable and also recent example based on COVID is researchers in South Korea recently came up with an algorithm. In this algorithm, they were scanning a lot of X-rays of COVID-19 patients to be able to identify any COVID-related pneumonia or tuberculosis complications or side effects that may arise. In this case, they're just feeding huge amounts of X-rays and letting the machine perform these pattern recognition, which is also, by the way, a type of deep learning. So there are a lot of already real-time use cases, day-to-day use cases of each of these things. So given these three areas, we spoke about artificial intelligence, machine learning, deep learning. What is data science kind of doing in this slide, right? And why are we even talking about data science? Almost all of the topics that are listed here depend on data science in some way, shape, or form for its applications, which means we need to use data science to enable artificial intelligence, to enable machine learning, and to enable deep learning. You can think of data science almost as a field that is comprising of like statisticians, mathematicians, analysts who work together in these areas to analyze various data sets that we may have. For example, in the X-ray use case, they're probably analyzing a lot of these X-rays, seeing what data makes sense, what metrics that needs to be tracked. Similarly, in like the voice recognition case with Alexa, they're probably also doing a lot of voice to text translation, trying to see what happens there. So typically in data science, large amounts of historical data is collected. This data is cleaned up and processed. Logs are built on top of it. Metrics are built on top of it. And in the end, all of this data is visualized in like a nice format, in a user interface friendly format, which kind of tells you and gives you trends of what is going on and what is important to track and what is not. Okay, so given this, why is AI such a big deal today? What is going on with AI and what is so important about it that we're discussing this today? Because interestingly, the word AI was coined in 1955. That's 65 years ago. So why is it only a big deal today? And why wasn't it such a big deal in the past? The main problem was that the capabilities of AI programming were very, very limited in the 60s and the 70s. Computers were only able to handle very trivial versions of a problem. So there were many fundamental limitations. Limited computing power was a huge factor. So for example, there was not enough memory or processing speed to really accomplish anything that was truly useful, because even calculators only came into picture much later, especially the complex calculators. Any simple process in general that required some computation time took exponential time to just get answers from it. So one big reason was we just didn't have enough compute power back then, although AI was coined and was something that researchers were looking into back then. The other big reason was the lack of big data. We spoke about how a lot of this requires data analysts to train, look at the data from historical perspective and make predictions based on that. With AI or artificial intelligence, you generally require this enormous amounts of data about the world. And to give you context, to just derive programmatical insights, one thing that people frequently say is that a computer is required to know almost as much as a child does, as a 10-year-old child does about the world, to be able to derive context and to be able to derive meaning. So that is a lot of data, and we just didn't have that much data back then in the 1950s. In fact, even in the 1970s, no one could even build a database that was so large. We didn't know in the 1970s how to hold data that was this large, how to process this data that was so large, and we didn't even have that much information to begin with. Another big problem, as with some research areas that face this challenge, is funding. So back in the day, funding in AI was not such a big thing. It was another problem. The research areas itself cost millions and millions of dollars to universities. And unfortunately, universities weren't able to convince people to give them that funding to even make progress in the study of AI. But over time, all of these fundamental processes and problems changed. And basically, the raw computing power itself was slowly being overcome. We didn't have a lot of these problems because in around 2010, first of all, access to massive volumes of data was no longer a problem. We finally had the internet. We finally had search engines. So again, going back to like requiring large amounts of data, right? One experiment, one of the first few experiments that was run in image recognition was image classification and cat recognition. What they did was collect huge amounts of cat and dog photos, and they trained models to be able to distinguish, if a photo is shown, which one is a cat and which one is a dog. And for that, they needed lots and lots of pictures of cats. And in the past, if it was like the 1950s, that basically meant that someone had to carry out the sampling by themselves. Someone had to manually go collect pictures of cats and dogs and be able to train it. Today, luckily, a simple search on Google saying images of cats, images of dogs, will show you millions and millions of such images. And hence that enabled the collection of big data. And because we now had big data, we could also train on these data and come up with artificial intelligence models, machine learning models, and so on. One fun fact about big data, apparently over the last 2 years alone, 90% of the data in the world was generated. So this resulted in a huge amount of data, which was obviously not even available before. Besides all of this, another big invention in computing, which enabled AI, was this thing called GPUs, computer graphics card processors. This supremely accelerated the calculation of learning algorithms and the computational power itself. So a program that would probably take weeks back in the day now only takes a couple of minutes, if not seconds. So much, much faster. And the cost of using this computation has also significantly reduced over time. And it's obviously only going to get cheaper by the day. This is an interesting image. So this image kind of puts everything I've been talking about in perspective. On the left, you see Apollo 11, which launched human beings onto the moon in 1969, to be precise. On the right, you see the latest iPhone. The computers that were in Apollo 11 costed around $5 million. And the phone on the right currently costs around $1,000, which is probably the most expensive phone in the market anyway. In terms of size itself, the computers in Apollo 11 on the left were the same size as a car in this day and age. So it's huge computers. And if you look at the phone on the right, you know it fits in your palm. You've seen all of the ads. You know how small it is. You have one in your pocket right now. So this is really the difference in computation that has happened over time. And it is much cheaper, right? Another interesting fact. Our smartphones are 1,000,000 times more powerful in terms of performance than the rocket on the left. So that is really how much computation, performance, speed has all improved over time, especially over the last 50, 60 years-ish. So, I mean, given this progression, one can only imagine what we'll be holding in our hands in like 20 years from now, right? Huge progression. And all of this kind of enabled computing at large. All right, moving on. Let's go down a timeline on this slide. AI is actually only, give me 1 minute, please. All right. AI is actually only the next iteration of data-driven decision making. And here's kind of why I say it's nothing but decision making and the next iteration of decision making. In the 50s and the 60s, we lived in a data poor world. We did not have as much data as we already described. So decisions were mostly based on intuition. For the rest of the slide, I will use an example of the sales of sweets going up in Diwali to make the case. We all know we buy a lot of sweets, a lot more than usual, especially around Diwali or during festivals. So let's think about like what a business owner or how a business owner would go about making this decision over the course of time and bring AI into this picture as well. So a business owner in the 50s or the 60s, they would know that sales of sweets would go up around Diwali, no brainer there. So what did they do? They went up and they stocked up a lot of sweets around Diwali time. Done, all of the decisions was based on intuition. This is the pre-computer era. Later on, as data and analytic tools started to become more available, leaders would make decisions based on data itself. And this is the data-driven decision that happened much later on. For example, they would say something like, okay, last 3 years, I know sales of sweets in India went up by 30% around Diwali time. This time, I'll go ahead and stock my inventory, increase it by 30% this Diwali also. So they know exactly how much more to stock and they know when to stock it also. So a little bit more idea. They have some data, they said 30%, they bought X number of boxes as a result of that. Let's talk about today. Today, the decisions are made based on big data. Big data is huge when we talk about AI and ML, and that's kind of why you'll constantly see the word big data in almost all of my slides. So coming to today, because it's made at scale, we are able to use sophisticated statistics. We are able to use big data analytics tools. And so business owners can make much more granular decisions. What kind of granular decisions? For example, a business owner is able to say, sales of sweets in Sheshadripuram store specifically went up by 40%. Whereas in Gandhi Bazaar, it only went up by 20% around Diwali time. So they will stock up accordingly. They won't send excess boxes to one location or the other. They will be able to scale their inventory based on location, based on this large scale of data, and also based on historical data that they have seen. What happened last year? What happened the last 10 years? If they can go back in time and if they have that data to begin with. Now let's talk about businesses of tomorrow. Businesses of tomorrow will be using artificial intelligence in almost every shape and form. And that's what we are all predicting, right? In businesses of tomorrow, we'll be able to use AI to make more real-time decisions using data at almost a hyper scale. An example would be something like, based on Madam Spandana's purchase of sweets in the past 3 years, we know she's interested in buying 3 packets of jalebi this year. Very, very specific details, right? So business owners in this case are able to make very detailed decisions. And by doing this, they're also able to add other variables in the mix. Not only are they able to predict Spandana Madam's prediction, they can make my prediction. They can stock up in different stores across various locations accordingly. And one more variable in the mix, just for the sake of this example, is the dates of Diwali are not really fixed, right? They're variable based on various calendars. They change every year. So if you just looked at analytics from the last 5 years and tried to say 15th November and kind of project it from there every year, that is not going to be true either. So you need variable dates also to be one into the mix of making this decision. So they can also stock all of this inventory accordingly, according to the accurate dates based on that year. So basically what AI is it's just the next wave of data-driven decision making. All right, this slide talks about various examples of AI. The previous slide, I think, mentioned a few examples, but this one is a little bit more widespread. This has a few more like AI specific examples that you've definitely encountered on a day-to-day basis. So on the top left here, you see an image of Tesla, self-driving car. If you have not already, I encourage you all to go to YouTube and check out some of the autonomous driving videos where the driver is not holding the steering wheel and just driving. It's fascinating to watch these videos. So that is one example. The other example is this one on the right, which is Alexa and Siri. Digital assistants, as mentioned, they're used in speech recognition. And you also have like Hotstar, Netflix, other video on demand with recommendations. They are using AI in so many different forms. Same thing with YouTube, Savan. They are also using, like YouTube, for example, if you go on their home tab, it's full of recommendations based on your viewing history. Big Basket and Amazon are also using recommendations and AI and ML algorithms heavily. Example is if you go on Amazon, on your homepage, you'll see tabs like inspired by your purchases or recommended for you in electronics or inspired based on your browsing history. More concrete example, in fact, might be even when you're purchasing a TV, you might see a little tab that says frequently bought together with. So when you're purchasing a TV, Amazon will try to recommend a TV stand or a TV mount or a remote control or a speaker, like products that go well with something like a TV is a recommendation, and recommendations are all using ML and AI heavily. Another example in the middle down here at the bottom is Google Maps. With artificial intelligence enabled mapping, Google scans road information, uses algorithms to determine the optimal route to take, be it on foot, be it in car, be it on bike, bus, train, and so on. So these are some common examples. Moving to opportunities. Okay, this is my favorite part. We've learned a little bit about AI, but practically speaking, we're all here for one reason. We want to know what this means for you. How can you take learnings from here, or how can you further your learnings in AI in any of these different fields? I've listed various industries here, but feel free to use the chat window if you want to share more industries that you might be particularly interested that we can talk about. But if not that, I'll get started with some of the examples here. In each of these industries, I'll try to list some examples of what roles you might be performing that is AI driven, what your day-to-day might look like. And with that, let's start with entertainment. And with entertainment, let's use Hotstar as an example. So Hotstar streams IPL in, I believe, about 6 different languages with around 160 million viewers. So huge scale. Imagine you were in a situation where the video got paused or you're seeing a lag during a very crucial moment in the game. That is a big no-no, right? These are the kind of opportunities, these are the kind of areas that you want to avoid. And the way you do this is by using machine learning. Teams would use machine learning to deal with traffic spikes, especially to control some spike in viewership. So they can do some analysis, ask the right questions to be able to scale enough to support the kind of demand that is needed during peak times or during live matches, during main events. Some of the questions you might ask in a role like this is, how many backup hosts should I have in case the traffic is more than expected? How can they reduce the number of hosts in case we're overscaled, for example? And how can we use your specific area in this particular field? You all can come in as a project manager, for example, and you can come up with all of these scenarios that a data scientist or an engineer needs to test. Like you will ask them, have we tested for traffic spikes? What about login issues? Are they all stress tested? What about the security aspects? What performance metrics are we monitoring? How are we coordinating with advertisers based on viewership? Because obviously advertising is a huge demand for huge events. All of these are, I think, intersection of your skills along with ML and how they can be used in a field like entertainment. Moving on to marketing. For this particular example, let's talk about the power of AI in, say, cosmetics brands in marketing. So AI has the power to completely reshape a brand and the marketing processes. In this case, you may come in as a brand manager. In marketing, it's very important to understand your customers, right? So machine learning can allow you to have these customized recommendations for your customers. So for example, if there is a tool that understands that based on my past purchases, I prefer only L'Oreal brands, then by marketing only L'Oreal brands instead of a Lakme brand, they are closer to a sale when it comes to my browsing. An other point of view might be, we all know that especially these days, influencers on social media play such a big role. So you would, as a brand manager, come in and suggest tying up with the right influencers. Suggest the team to build out a dashboard, for example, to get metrics on things like this. So you would ask questions like, what is the frequency of a purchase, right? How can we get these information from the data that we have collected? What brands have our customers previously preferred? How much of a brand should we stock up around what time and when? And maybe one customer only prefers products without parabens, without toxins. How can we make sure that we have our inventory adjusted accordingly, or we have recommendations also accordingly? You also want to understand which of the products make up a larger part of a market share. Like, is it skincare in your particular brand that does better than oral care maybe? So coming up with all of these ideas to marketing the right product to the right customer can be achieved through AI. And I think this is how you will all be able to contribute in something like marketing. Moving on to banking, we spoke about the creditworthiness example when we discussed machine learning. Your role specifically here will be to try and understand how lending would work in an AI-driven world, for example. So before, you probably had customers fill in a lot of forms, send these applications. These applications need to get evaluated. So all of these can take quite some time. With AI, you probably need to redesign this whole process that is being followed. So one possible role that you people can have here is that of a process builder. You can evaluate what steps are needed to be taken to change the process. And as a result, what is it that your team of engineers need to build for you so that you can provide the right data and the right decisions for your customers. Moving on to sports. AI plays such a huge role in sports, especially in sports analytics. Let's talk about cricket, because cricket is cricket is a huge numbers game. A lot of predictions in cricket actually can be made by using data like runs scored by a batsman, what is the wickets that were taken by a bowler, how many matches were won by one particular team when they played against another team. The number of times a batsman responds in a certain way to one kind of bowling attack. We can dig into thousands and thousands of cricketing numbers, right? And all of these can be used to improve performance. And this is a huge deal today. It can be used in so many ways. Things like predicting a match outcome, score forecasting, trying to find the fitness of a player. Some of the more important examples are maybe real-time data analytics. So with real-time analysis, you can help gain some insights that can make some changes in the game. You can use these insights even during the game for changing some tactics that is used by the team if you think that that is more favorable for the team to win. So if you're someone who understands all the moving parts of a game like cricket, your knowledge is extremely invaluable for sports analytics. And there's a huge future here, especially for the intersection of sports analytics and how AI is used in this field to build out various models to obviously make sure your favorite team wins. Let's move on to education. In education, your role can be that of something like a product builder, perhaps. So an example can be, even if there are parts of a paper that you're scoring and that you're grading, if parts of it can be automated, that means it frees up a professor's time to spend more time with their students. And that is also very valuable. We all know that. Taking it a step further with something like adaptive learning. What are some products that should be engineered? Maybe as someone in education, you can identify that maybe we have more teacher AI collaborations. Those are required. Maybe we develop some customer software for individualized learning. Maybe we can automate some admin tasks for teachers. Distance education is one more place where AI can play a big part. And maybe even providing a gamified version or games of teaching various things. can make it easier for teachers to interact with special needs students, for example. But as an educator, you are in a role where you would be able to envision all of these opportunities and guide the team to build the correct models for these solutions that can enable educators greatly. I'll move on to, I guess, skip analytics, move on to real estate. This is a sector where AI is actually already being used very, very widely. So as an employee in this sector, maybe you're in finance, maybe you are a real estate agent, you will think of what are the different themes of decisions that can be made to leverage AI. For example, you can create some simple digital assistants to answer some common questions. Based on data analysis, maybe you've seen that the most common questions are things like, how many bedrooms are there in this apartment? Thousands of people are asking the question. How many cars can fit in this garage? Does this house have a pool? A lot of these simple questions can be automated by using digital assistants. Or using machine learning and a database of clients. Let's say we want to find the right seller for this house that you're trying to sell. Using machine learning and this database of different clients, we can build a product that kind of pools all of the potential clients for the house that you're trying to sell to find the right customer to sell it to. Or you can also use machine learning to predict appraisals or the market value of the house, because the market value of a house is variable based on so many factors, right? It depends on the economy, the location, the year that was built, and thousands of other factors that go into finding the exact value of the house. All of those can be parameters to a machine learning model, which will then predict the answers that you're looking for. Moving on to healthcare. For this example, let's take a slightly different role that we haven't discussed yet. What if you were in sales? So if you were in sales, maybe you're not a direct user of this product, but you still fully need to understand what it does in order to be able to convince, let's say, doctors to use it. So maybe this product uses deep learning to read radiology reports or x-rays. Your job will be to explain how it works, how machine learning and this product operate together, what are some success metrics that have been used based on which this product was measured, and finally convincing the doctor that this deep learning product can actually read radiology reports. I'm sure many of you listening in today who will be very interested in this field of sales and additionally are good at this. In your case, the engineers and the data scientists of the future need your help to make their product a success by being able to sell it to the right customers as well. I'll probably move on to retail next. So with retail, I think I'll kind of end my storytelling about opportunities with retail. It's an area that I work in and understand well. An example role I would like to talk about here is that of a product manager. One of your responsibilities here would be to predict a customer's demand and help drive operational efficiencies. So for example, around Christmas, the sale of potatoes drastically rises in the United States. So in retail, you'll be making decisions like how to keep the stock high, yet you want to make sure that the wastage is low. You don't want to throw away all the excess potatoes by just hoarding a whole bunch, right? So let's assume you work in retail like Big Bazaar. As step one, you will need to make sure that the inventory is being tracked. So you will go to the companies that sell you potatoes directly, and you will advise these companies to use a nice user interface to input all of these data. So they will add data like when did they purchase, how much did they purchase, how much did they sell it to you for based on the timeline. Step two, as Big Bazaar for you, you will need to feed this data into a machine learning model and have your engineers and data scientists build models based on the parameters that are important to track. In this particular case, obviously we want to track sales. Everyone wants to sell a lot, make profits out of it. You also want to track things like how much was it when you purchased it? And you want to make sure that there is no wastage. So you want to track to see that there was no wastage as well. So over time, what happens is you end up building a good feedback loop from the seller of the potatoes to you as Big Bazaar, to the buyer of the potatoes, making sure that there is a data-driven approach to stack the inventory without any wastage. With these examples, I hope you all understand that each one of you have a very key role to play in the jobs of the future. You may start in sales, you may start in marketing, finance, analytics, product management, process management, etc., etc. And you may, like, what would a career path look like? You may go on to become single-threaded leaders who lead the business from a data-driven perspective, with a wing of engineers and analysts under you helping you make these decisions. So you're all extremely well positioned with the specializations you listed at the start of this talk to take on these challenges in so many different industries and drive small and large companies to really transform the global economy almost. With that, my last slide for today, what can you do to prepare yourself for the job market of the future? There is a very popular course on Coursera. You can take that course. It's by Andrew Ng. He's a Stanford professor who has taught an introductory course that is accessible to all for free. It's a good course, highly rated. You can also read up industry reports that are written by global thought leaders, by Boston Consulting Group and other such companies. When you talk to industry professionals in your everyday life, or maybe even when you talk to your alumni of the college, ask them how they're using AI and artificial intelligence and machine learning in their workplace. Besides that, I guess YouTube also has a good selection of videos to learn from. There's always something for everything on YouTube. But I think the goal of all of this is when you access these resources, it should not be so much about uh, getting to the depths of the technical understanding of AI, but rather to get an understanding of the vocabulary itself, the capabilities of artificial intelligence, and the limitations of artificial intelligence. With this overview, you must be able to absorb it from a critical point of view and maybe how it can be applicable in your career and in the industry in the future. With that, I would like to open it up for any questions you may have. If not, if you want to talk about anything specifically, happy to go into any of those details. Let me know if there are any other questions in the meanwhile. Thanks, everyone. Thanks for your time.
Yes, this was one of the most awaited sessions by our students. So students can post your questions in the chat box, or you can also unmute yourself and ask the questions. Option open again. Any questions?
Excuse ma'am. Excuse ma'am.
Yes.
Ma'am, my question is about that AI only, ma'am. Why are they not collecting all the algorithms and induced into one to use it more or use it properly? Why only that YouTube has only videos uh, and other Hotstars has movies or everything? Why can't we collect it all and induced in one?
Hi, Anupam. Thank you for your question. It's a good question, right? You're saying, why can't we take it 10 steps ahead, 20 steps ahead, and do more with what we already know? I think the answer to that is we're to some extent doing it. And to some extent, we can also not do it because the use cases are so different from one case to another. So in YouTube, you're specifically looking for what was the previous views of a particular person, and hence what the recommendations for those videos can be. So what is the input for YouTube? The input for YouTube is all of these signals that you are giving them about what you're watching. Their data source is the vast collection of videos that they have. And so the one thing that they can recommend from the data source and from this input is more videos for you to watch, or videos that you might be interested. Amazon, on the other hand, they're selling completely different products, or even like Big Basket, for example. They're trying to sell some e-commerce products, or let's say they're trying to sell electronics. So if someone's looking for a phone, they want to be able to say, what is, if you're looking for a specific model, maybe what are something other products that you're interested in. So as of now, a lot of these have been very use case heavy and driven specifically based on that. Autonomous driving, very specific to that. And to be able to learn something like autonomous driving itself is such a huge task that they require more and more data to be able to fine tune it further. So a lot of the focus has been to deep dive further in one specific area and build more. To answer your question and coming back to what you had said, there are, however, fields where information and output from one algorithm is kind of used into another algorithm as well. In fact, within neural networks, there are multi-level neural networks where they can use outputs from one and treat it as an input for another. Or to give you another example, something like in a place like Amazon, if they already have information about, let's say, like your purchase history in electronics, they could perhaps use it for something else, maybe subscription for something else, for example. Or if you're buying some video, maybe they can suggest a subscription for some video purchase model. So there it is happening to some extent, but right now what you're suggesting, I think, is more of a divergence rather than convergence. And right now they're looking to kind of improve each of these in whatever shape or form that is possible. So maybe in the future it is possible that we can derive even more insights from one industry into another. I hope that answers your question. If not, feel free to repeat it and then we can discuss it.
Yeah, ma'am, it's done.
Okay, thank
We
you.
have one question from Rahul Solanki, ma'am. Do you support copy pasting from open source?
Yeah, so Rahul, good question, because I love contributing to open source. In fact, in search, there are so many open source technologies that I am learning from constantly on a day-to-day basis. And I'm sure a lot of people also do in various different industries, right? In general, this would differ company to company. So I can speak from an Amazon perspective. From Amazon, at least a lot of the code that we use is proprietary within Amazon because they're all specific to AWS, which is Amazon Web Services. We use a lot of those tools. But there are also some teams that do use open source technologies, in which case not only are we using the open source technologies, and like you asked, are you copy pasting and using data from open source? Yes, we are, but at the same time we're also contributing back to open source, because in some areas we're such heavy users of open source. If we find that maybe there is a bug that we can fix, if there is something that we can improve, and if we have seen, say for example, using version 5, we have seen that making this code change from this to this causes our latency to improve from 50 milliseconds to 10 milliseconds. If it has helped us, we know that it's something that can help everybody else in the open source world. So we are also active committers in the open source world, where we go back and share this code and commit it back.
Thank you, ma'am. Any more questions? I have another question from Rahul. Is there any platform like GitHub from Amazon?
Hey Rahul, thanks for the next question. So is there a platform like GitHub at Amazon? So there is. In fact, we do use GitHub itself, but we use Git as is without the hub version of it. And we built on top of that. So everything looks the same. We're still using the same commands as Git. So there is no like learning curve for an engineer. If you know Git, you already know what to do. I think with most companies, they use Git as is, instead of like kind of building something from scratch. So we don't build anything from scratch like GitHub, except we just use a different interface. We just use a different user interface that just looks a little different, but behind the scenes, it's basically GitHub. So yeah, it's the same thing. With respect to, I wanted to add one more thing to your previous question. So in combination with GitHub and open source that you asked, so Amazon's code itself, not all of it is open source. Some of it is open source and some of it is not open source. And I think that differs again from team to team and the product to product. This is true with, I think, all other tech companies as well. From team to team, product to product, some would be open source and some will not be open sourced.
We have the next question from Anvita. What do you say are the common misconceptions of artificial intelligence?
Hey Anvita, great question. So this can lead us into a nice long debate, and I'm happy to talk about that, but I'll try to keep it a little short. This is a very interesting area because I always also like to talk about both the pros and the cons of a particular approach or a particular industry. With something like AI, I think the biggest misconception that a lot of people have is the fear of privacy. So with machine learning, artificial intelligence, one thing you will hear is, oh my God, they're using my data. I'm scared. I'm not going to share my data, right? But the interesting thing to note here is the data that is being used is not at all granular. It is at a much, much high level. So at the end of the day, the data that is being shared is, say, one data point in 1 billion data points. So there is no way to be able to trace that one data point to say this came from Anvita or this came from Chandana, just because at the end of the day, none of the data is personalized. In fact, legally, the data is not allowed to be personalized. You can get sued if the data is personalized. So all of it is just obfuscated at the end of the day. I think that is one big misconception that does exist in AI right now, that all of the data is highly personalized and can be traced back to a person. That is not necessarily true. Another, like, I wouldn't say misconception, but I think this is one more thing that is not fully like understood. I feel like the power of AI is really still not fully understood, in the sense that it can do so much more than we think it can. And with that case, I think some industries especially have accelerated and gone all out with the use of AI and machine learning, and some industries have not. To give you an example, with banking, only in the last few years did banks start leapfrogging and using some of these concepts in things like credit score analysis, new bank accounts, new branches even. The misconception I would say here was that some of the industries took it slow, where they didn't believe as much in the power of AI and ML. But once they started seeing other industries leapfrog and really make progress with these kinds of recommendations, they also onboarded with it. So some new startups in banking like Plaid, Stripe, they all really did pick up a lot, and they started with a base of machine learning. And now you see a lot of the banks of today, or maybe even banks of yesterday, try to catch up to do the same.
Okay. Any more questions? I think. Okay. I request Shivkumar sir to please propose the vote of thanks.
Thank you. A very good afternoon to all of you present. Friends, it's not the happiness that brings us gratitude. The gratitude is the thing that brings us happiness. So on this note, it's actually the time to express the gratitude and thanks for everyone who has supported us in organizing and conducting today's event very successfully. As a convener, Mantana Research Cell, it's an honor and privilege to propose vote of thanks on this occasion. First, I would like to thank the management, Sheshadripuram Educational Trust, for extending all the support in organizing and conducting this event successfully. So next, I, on behalf of management, principal, staff, students of SICM, Sheshadripuram Institute of Commerce and Management, would like to express my gratitude and thanks to Mrs. Chandana Prakash for accepting our invitation and giving such an insightful presentation on artificial intelligence and various career opportunities in the field. Thank you, madam. So I also thank our beloved principal, Professor Vidya Shivananavar madam, for her constant support, encouragement, and guidance in organizing this today's webinar. Thank you, madam. So I would like to thank Professor Spandana, convener, Mantana, the research cell, for her effort and support in organizing today's event very successfully. Thank you, ma'am. I would like to thank all the teaching, non-teaching fraternity and students from SICM and also various colleges for their active participation and involvement in making this, today's webinar very active and, very nice session. Thank you all. I would also like to thank Mr. Dilip sir from Administration Wing for all the technical support he has expended in organizing this webinar. Thank you, sir. So at last, the feedback link will be mailed to your respective mail IDs. So on filling and successful submission of the feedback form, you will be getting the auto-generated certificates to your mail ID. Once again, I thank one and all for your participation and also making this event a grand success. Thank you all. I wish you all success and a good health, and stay safe and take care. Thank you all.
We still have a lot of questions in the chat box, ma'am, and you're also addressing them.
Yeah, I can go over the remaining ones but I think we're also out of time, so I'll let you make the call. I'll probably take it shouldn't take too long. I'll probably take a couple of minutes and then conclude. Tasmi, I think with your question, overfitting, very good question. This is our daily problem. On a day-to-day basis, we're breaking our head about overfitting and underfitting all of the time. This is a very, very pertinent question to something like machine learning, especially when we talk about big data, because there are so many parameters. So to just kind of keep it short, the answer is to try and find the right amount of parameters, right? And there is no right answer to any question. So it will depend from algorithm to algorithm, and you'd have to find the right number of parameters and metrics. There are a few interesting research areas about this as well. So I'm sure you'll enjoy those reads to see how overfitting can be fixed. I think the last question was, a lot of people seem to fight against or have the fear of AI. I think it's the same thing, Charan, as one of the questions that Rahul also had, which is, will AI steal our jobs? There is a fear because it's almost like the computation power is infinite. So the question is, what can it do in this infinite power? But at the end of the day, I think it's as simple as being able to trust human beings to do the right thing, and also guard us to not program or do anything that is, not the right thing to do. And hopefully by having the right ethics and the right morals, we will be able to do the right thing and won't do anything that's unworthy.
I think all the questions are answered. So thank you so much, ma'am. It was a pleasure having you among us. Thanks a lot.
Thank you so much. Thanks for your time, everyone. I hope you have a great rest of your day. I thoroughly enjoyed talking to you all. Have a good one. Thank you.